Okay. Hello, everybody. My name is Jonas. I have the pleasure to chair the next session, which is Applications 2 this afternoon. Sorry for the short delay, but we had some technical issues which we hopefully have solved now. And it's a pleasure to give the stage to Stefano, who is also a fellow PhD student. And he's presenting you Microservice-Oriented Computing for IoT Applications.
Thank you, Jonas. Well, good afternoon, everybody. I know that every one of you wants to go have a beer with the major, but I will try to make it quick. And this last session of the day will be, I will begin this, and it will be on my, let's say, relation report on the usage of microservice-oriented computing for a specific domain that is the development of IoT applications. First of all, so let's start from the domain. What is an IoT application? What can be an IoT application? And which are the context of IoT applications? Well, I just put there something that could come on your mind when you think of IoT applications, and divide it into macro categories. One of them is digital infrastructure. So when you think of an infrastructure in the digital city or in the smart city, call it whatever you want, you can think of it as a smart building management system, for instance. So for example, something that has inside a surveillance system, something that has an environmental quality management system, or just simply in general a monitoring system. And you have a bunch of examples in that. Then when you think about infrastructure, or slightly separated from infrastructure, you think of smart mobility systems. An example of it could be, for instance, smart parking, that is related with the topic of Internet of Vehicles. I don't know how many of you are interested in those kind of things, but now there's an Internet of whatever. And vehicles are one of those things that are actually things, but not things in terms of thing, but things in the term of, and I'm stopped like this. I will not say more thing in my life. Okay, another another application example could be a smart routing system for public transport. And in a moment, I will tell you another word that I will never say anymore. A second example could be when you think of the category of digital well-being, aka e-health. We have fancy names for everything, and one of them is digital well-being, but we refer to the e-health management system. And for instance, you will have a wonderful speech by someone in this room later about an example of smart diagnosis systems that is basically including bioinstrumentation, sensed data into an electronic health record of a patient. This is just an example. Another example could be in digital education. This is one I really like. Learning analytics system. So to take usage data from the learner and to discover information for advising people's learning. This could be something used in the university as in the high school, everywhere. And just as a remark, these three macro categories that I identified were identified by the H2020 European Union Commission as key drivers for the smart city. So stop with the publicity. Basically, an IoT application is whatever, put smart after, and that's the second word I will never tell anymore. So put whatever after smart, and that's basically an IoT application nowadays. But what characterize IoT applications? So from an architectural point of view, IoT applications are distributed systems. The slightly difference is that we are talking about heterogeneous platforms. Okay, so I want to stress on the word heterogeneous. And the second thing really important is that we have delocalized topologies. Okay, you have a bunch of sensors somewhere in your network. Then you have some other node nearby the sensor, but not so close. And then you have cloud somewhere. So from an architectural perspective, the context of IoT application is this one. Okay, so we refer to this architecture in all the remaining of the work. We have cloud services, data storage, dashboards, whatever. Fog and edge, I put them together. They used to be called middlewares, actually, middleware computing or whatever, but now we want the fancy name and we call them fog and or edge. And which is the difference? I will try to tell you, and I will have a disclaimer on that because it's really difficult or hard to say. This work focus on the edge computing layer, so to say one of the middlewares, okay? But just this work, what I say will apply to every part of the stack. And the bottom layer is the thing layer. So thing intended as a thing, a device, okay? Another remark, when I say distributed system, I refer to this. I refer to the fact that we have cross-layer communication, and we have inter-layer communication. So we want to communicate, basically an IoT application communicates with all the layers, all the 3 layers, and then communicates even inter-layer. So you can communicate through different edge devices, you can communicate from a thing to a cloud service, you can communicate through cloud services, you can communicate through things. This is the reference architecture. And what about the developing perspective? So the developer perspective, I remember Steve Ballmer. Saverio always remember me or Steve Ballmer saying developers, developers, developers. So from the developer point of view, we want, and I thank Olaf because yesterday just simply told me what I put in this slide. We want modularity in our IoT applications because think, for instance, how much we want to be the application updatable, okay? We want consistency, think of how much secure we want our IoT systems that deal with our personal data, personal medical data, for instance. And since now, we just need service-oriented, okay? As Olaf told us yesterday. Plus, we need scalability. I don't know if you're familiar with something like SaaS, that is sensing as a service. So it's kind of, I want to sell per sensed measure. In such a scenario, I want to be scalable. I want more customer to subscribe to my service, and then I have to scale. I have to serve the first one as I will serve the 10th millionth one. And then I want agility, of course, because I want to be QoS compliant, quality of service compliant, or whatever. I want to be compliant with my customer needs. And so I have to change functionalities. And so this is where microservices comes in end, because they provide this to me as a developer, this provide to me this thing plus the service, so the service-oriented plus those needs are addressed by microservices, okay? So I want to remind you that this is the architecture, just a reminder. What we have, actually what we had since yesterday, was actually a more cloud-centric perspective. Since SOA and SO microservices born in the field of, were web-driven, so born in the field of web, they are basically more related to the cloud. So have been used now, since today, they've been used more from the cloud perspective, okay? So a few works nowadays are addressing even the other layers, but most of all, since now they were used just for the clouds. Okay, I will go through some definitions, some history. So we want to address this, and what we have now is kind of this. So microservices are used in this scenario, but we want to use that in this scenario. Some definition, because it's not, I cannot give for granted that every one of us has the same definition for those layers. So I define a thing as a device or a set of devices equipped with sensor or actuators and actuators, and possibly some communication technologies. Otherwise, it will not be actually an actual thing. And possibly wireless or not, whatever, a communication technology. What my definition of edge device, and the disclaimer is that this definition is not it doesn't have consensus enough, actually. If you go for IEEE and look for edge devices, you will find everything, basically, these days. And what I saw in practice is that edge devices are actually used for local computation. So I have something that is not powerful. Maybe it's a thing, okay, per se, it's a thing, but I want to compute something. So I want some computational power more and do something on the data that sensor produces nearby the source of the data, okay? For instance, maybe I want to do that. The reason could be I want to be compliant with GDPR, so I don't want to, I want to move to work on the data where they are produced. I don't want to data leave the building. Think of smart home systems or smart, I said it, or e-health. You want the data to stay there. Or they can be just controllers. Think of a bunch of actuators. I want to actuate on something, I need a controller. Or they could be collectors. I want to monitor some sensing data and I want to collect them and, for instance, compute the average before to send into the cloud. That's the typical example. So what about fog nodes? Every one of you maybe think of edge devices as fog nodes and the opposite. But what I came to know is that fog nodes are communication middlewares, are the old-fashioned communication middlewares, okay? Because they talk with the other layers, so they are middlewares that talk with the other two layers, while edge is more an interlayer thing. Okay, they could be, you heard about them, they could be proxy or API gateways or brokers, for instance, for publish-subscribe protocols. Okay, so what is the question of this work? The question was, well, this is the context. I explained to you the context. Now I want to know which is the best solution to develop such an application. Okay, this is quite natural. And some background before I will continue. I studied bioinformatics before to do my PhD. I have a master's degree in biology. And when I thought of people thinking of me as a bioinformatician, they think of Terminator. Okay, oh man, you're doing Terminator stuff like that. And when I started my PhD in computer science, well, things changed a bit. Okay, so basically they didn't think I did Terminator, even if it was more, it fits more actually. So the thing was, except for the joke, that was the funny slide. Computer science deals with programming languages, okay? Computer scientist. So the answer to the question that I made before, okay, which is the solution, it's a programming language, the solution, okay? So the choice now, that is the most important thing, is we want to extend an existing solution or we want to start from scratch. The answer is Jolie, in the sense that there's something there, and the reason why is that they pay me. No, it's not. Actually, they don't pay me. The reason was because it already supports technologies for integration. That's the reason. Okay. So we don't want to start from scratch. We don't want to reinvent the wheel. We need something that is that has yet some technology. So some technology stack available, and as Fabrizio told us, Jolie actually has everything that one needs to speak with the upper layer, but is ready to develop, to be extended, and to talk with other technology stacks. Okay, it's really important to have. So we divided I divided into three category. We have application protocols. Actually, it's wrong. It's the opposite. It's application protocols. It's like HTTP. Maybe some one of you noticed that. Mediums are TCP, Bluetooth, RMI, and data representation are XML, JSON. So this slide actually is wrong. So we build an extension for the Jolie interpreter. We call that the JIoT project. That stands for Jolie for Internet of Things. And what we did concretely is to fork the interpreter. Nowadays, maybe it will become in the master GitHub repository. Maybe it will fork. but we don't know yet. And what we did concretely is to develop two extensions, because we found out that from literature, the two extensions, and from the practitioners, the two protocols, application protocols most used into the Internet of Things are basically MQTT, that is an asynchronous application protocol for publish-subscribe message exchange, and coap, that is a lightweight connectionless-oriented protocol. So to talk with the thing, so to fill the gap between the edge, the fog, and the thing, we needed to extend Jolie with those protocols, okay? So not a big deal, just 2,000 lines of code. Not a big deal, a PhD student can do that in one night. Remarks on that is that we use Netty.io. The Jolie interpreter is written in Java. It's built on top of the JDK. So let's say to make it faster, to speed up the development, and to perform and to stress on the performance that a language should have to handle IoT applications, because we are talking about millions of sensors in a near future, or at least an application could have thousands of sensors connected, or actuators. Netty, if someone of you doesn't know, I put the references at the bottom of the slides, and is an asynchronous event-driven Java library. It's basically a Java framework to develop event-based network protocols, to develop in an event-based way network protocols, and we build with Netty, coap, and mqtt, and then we built the UDP support, so connectionless support for Jolie. And a remark, since it's composable Jolie, you can actually put any application protocol on top of any medium. So you can do fancy stuff like putting, I don't know, HTTP over UDP. You can do that because it's composable. So you can compose the medium with you can write a datagram and HTTP as application. I wouldn't, don't tell Fabrizio that I did it, that I told you, but it's you can do that. And the first things that we did, and was quite tricky, was to actually provide an end-to-end mapping implementation to the publish-subscribe paradigm of MQTT, because we need this thing to handle the communication, that to be able to perform a synchronous and synchronous call to a broker, we need to map this thing into the interpreter of Jolie. So this was concretely what we did. And well, I don't think if I have time for the code, maybe not, but for the live code. But the point is, you already know that Jolie has a part that is the behavior, in which you put the logic of your application. And if I want to express a simple logic, then there should be a simple behavior. If I want to express that when I'm back home, I want to toggle the light, okay? And if I'm back home, I want to toggle the light through. Remember that since Jolie has input ports, so input operation, I don't have to say if back home. I don't have to take the return of that function. I just say when I back home, I will toggle the light, okay? So this is the behavior, and this is part of the deployment, and well, it's quite simple. I'm using a service, an input service that is a door, and I want to access a output service that is a light. And the operation, Jolie, you didn't see that, you didn't show that, but Jolie has even inline interface definition, that one way back home is not like the one that you saw today, is not interface something. I can write them inline, so in the deployment part, in the port definition part. And so what I'm doing is simply say, when I'm back home, I want to talk with an HTTP protocol, that is the location. And as you see, no, it doesn't. As you see, the protocol of the light output port is coap, so that's the actual extension. and the location of coap is datagram. Okay, it has the medium is datagram. So these are the user what the user see when I told him these are the extension of Jolie basically. And of course you have all the fancy things of Jolie, you can change them, and that's the second extension we put as a protocol, mqtt. Of course mqtt, it's a middleware that talks with a protocol that talks with a broker. Okay, and so we have to say not in the location, because the location it's input. I'm waiting from the broker at the location, but I want to communicate with the broker. That is mandatory to express where the broker is at that address. That is an IoT Eclipse sandbox for testing mqtt broker, for mqtt requests. Okay, so you can use stuff like that. You can use even local brokers, local implemented brokers. I'm at the discussion. I mean, I can show how much time I have.
We're a little bit behind schedule, so if you now go into details, we won't have time for.
Okay, I will not go into details. So the discussion, I just to foster the discussion, I just put there some pros of doing that. The pros is that it's really easy to program. I mean, it couldn't have been easier. It's easier. It's not easy. It's easier. You have this strong separation that helps a lot in the developing of the IoT applications. We are doing, as I told you, we are doing edge computing here. So this project, this specific project, was just for doing edge computing. But you can talk with more complex cloud services, or I mean, you can do whatever actually. You can even implement a gateway, so a fog node in Jolie, as you already saw. Another pro could be that it becomes easy to emulate lower level components. If you are in a setup in which you want emulates other components, since Jolie you can implement, for instance, for the coap, you can implement even the client side, but the client side would be a thing. Okay, since Jolie interpreter is on JDK, you cannot put Jolie interpreter onto Arduino, but you can emulate it. So you can actually perform emulation of it. And as a future work, of course, there could be, as a top-down approach, go to the Arduino and I don't know, build an interpreter written in a lower level language. Well, as cons, but I wouldn't say, I mean, it's the only thing that I saw in the developing, but this actually is even could be a pro. We still need an extension specifically crafted for Jolie. So we need to develop in Java using the framework. We need to develop the Jolie extension. But still, this is community-driven Jolie. So actually, it will be implemented only what is needed in this sense. So it could be even a pro. But this is just suggestion for fostering a discussion. So this is the team. This is not the team. We wish to have a boat, but this is not the team. No, the sense is that we are all on the same boat. We are all on the same side of the boat. You know what happens if one of them goes to the other side on a sail ship? Yeah, just one of them. So if one of them goes to the other side, the ship sink, actually. That was more or less the message. And so give us money to buy the boat, I would say, but no. Okay, that's my contact. If you want some suggestion, yeah. If you want suggestion how to use this system or Jolie for IT application, just please contact me. And that's it. Thank you. It's time for questions.
Okay, so because we're a little bit behind on schedule, maybe just one quick question. I saw the guy here, and maybe you can solve the other questions afterwards, if it's okay.
Thank you. So it's a very nice talk, because it is exactly the right direction that we are doing, and in our team we are also doing in that direction as well. But it's a little bit from the other way. So we have the Tingamel language that is more a language that's specific for IoT.
Mm-hmm.
and it is that.
So
but
lower level.
Yes, that's very low level. So it means it can be compiled to Arduino as well.
Okay.
C and everything so it even down to the level of IoT devices, right? But I think it's the same approach in terms of the communication protocol that need to be supported. So it means you address that part.
Mm-hmm.
And I find that in your approach it's interesting because it's support for microservices view, and we are doing it now with
Okay.
TML.
So you're planning to migrate to
also support for microservice architecture as well in using TML.
Yeah, I mean, having it natively gives you the possibility of simply thinking in that way. So from scratch. So when you start thinking about the entire application, you start thinking in microservices terms. So I think that's a good way of doing this. So if you're going there, go there.
Okay, so just so then it means I also curious about in your part. Do you see any kind of security things that you want to support in your language?
For security, what do you mean? I mean secure of IoT application, secure of microservices.
First of all, microservices. I think that could be interesting for the conference as well, right?
Yeah.
So if you have any thoughts about that.
So implementing security, is that right? Implementing security with this system.
Yeah, like for supporting for security.
Well, it's okay. Well, maybe I didn't mention it, but again, since even the developing extension is compositional in Jolie, you can implement the secure layer as a plugin, basically. So if you want to use all of those protocols with their secure version, so with TLS or SSL, let's say, layer on top of it, you can use it. And actually, they are implemented. So you can use all of those protocols you can use in their secured version. Yeah, you can use HTTPS, you can use coap S, actually coap S, it should work. Yeah, it works, definitely. Again, I was thinking, no, again, the thing is that actually since it's really thinking compositional terms, it's challenging because it pushes you to think that everything could happen, but you can control it. So it really gives you the ball of the choice. So I was thinking that, okay, SSL on top of coap, why not? Actually, the secure version of coap is use TLS. So you can, all of the protocols, if for securing the application you mean use secure protocols, you can do it. You can do it now. And the thing is that how much easy is to implement this extension.
Okay, so maybe you can switch the security discussion to the next
of
break.
course, yeah.
You already spoiled us some fancy e-health case study, and apparently we have the author of this case study here.
Yeah.
Give a first of all applause to you, Stefano. Thanks